Biology, I'm going to go over a couple things that were in the chemistry of life notes that I made for you guys. Just kind of stuff that I can't just go over when doing the recorded lesson. Okay, first thing I want to look at the structure of the atom. So the atom is the smallest unit of matter. It has 3 subatomic particles within it, the proton, the neutron, and the electron. So I'm going to draw an atom and talk about its different parts. Let's start off with 2 dots here. And I'm going to add 2 with it. And put 2 on the outside. All right, so here's the structure of the atom. I'm going to add one more thing to it. Those colors are supposed to be different, but they look the same. That's okay. Okay, here's my atom. The center of the atom, this is called the nucleus. The nucleus is also the word we use for the center of the cell, and cells are what we're going to talk about next, probably starting at the end of next week. We still have some things I want to do with the chemistry. The 2 types of subatomic particles that are found within the atom are protons and neutrons. So we'll say that this red one is a proton, and we'll make this blue one the neutron. So one of the attendance questions, you were supposed to tell me what the location and charge was of all the different subatomic particles. So this is it. And then this one is the electron. I'm going to go over the characteristics of each of these, and then we'll move on to the next thing I want to focus on. So the electron is negative. So you can think about if you get struck by electricity, or struck by lightning, those electric signals coming from that would be negative. So that's how I think about that. So electrons are negative. If we're talking about location, I'm just going to put an L for this. Location would be the electron cloud. In mass, it's very, very tiny. I'll just put very small. It gets 1 over 20,000th of the size of a proton. So it's very, very small particle. So that's the electron. Okay. And just so I have this labeled like everything else, this is what we call the electron cloud. Protons. Protons are positive. So they both start with a P. That's how you can remember that. Positive. Its location is the nucleus. And its mass, it's actually going to have just the general value of 1. And then your electron, I think this is in the notes, but it's 1 over 20,000. So it's super, super tiny. So that's our proton. Positive. Nucleus is location. Its value is going to be 1. So let's talk about the neutron, and then that'll wrap up the atom. So the neutron is what we'll say it's neutral. So if I'm going to do symbols for these charges, my negative is going to be just the minus sign. Positive is traditionally the plus sign. And then what I'm going to do, if I ever do stuff to show you the charge of a neutron, I'm actually going to use a 0 for neutral. Its location, it's also located in the nucleus, just like the proton. And its mass is actually also a value of 1. So its mass is equal. It's about the same as a neutron. So again, these couple terms, we have electron, which is negative, located in the electron cloud and very small. or 1 over 20,000. It's the electron cloud is the circle around this, and then our nucleus is the portion in the center. The nucleus contains both protons and neutrons. Protons are positive and have a value of 1, and then neutrons are neutral, also located in the nucleus, and also has a value of 1. So that's the structure of the atom. So that's the first thing I wanted to go over. The second thing, I'm going to get rid of that paper too. Second thing I want to go over is actually just very briefly the periodic table. The periodic table is what we use to show all of the different elements that we have. There are 92 naturally occurring elements. The largest element that's natural is uranium, and uranium is thought to be created within supernovas. So it takes a lot of energy to create uranium. But what the periodic table does have in common, no matter what element we're talking about, you can figure out the same information for all of them based on their section of the periodic table. And I'm going to use carbon. That is the one I used in the notes. Okay. So carbon has an atomic number of 6, and its atomic mass is 0.11. So what does this actually mean? I'm going to go over these. So this right here, this is called the atomic number. Okay, the atomic number. The atomic number is going to represent the number of protons that you have in an element. This is never going to change. So you have the number of protons. If the proton number changes, you actually end up with a new element. So that doesn't change. Now the second thing right here, this is called the chemical symbol. The chemical symbol is either 1 or 2 letters, and it's either based off of the English name for it, the element, or a Latin name for most of them. Okay, so carbon is English. If I was going to use an example of a Latin one, so in the notes I use Arium. Arium is actually the Latin word for gold, which is why the symbol for gold is AU. So that's why if you see some elements on the periodic table that you can't tell what they are, or their symbols don't seem to match their English version, that's because they're named after their Latin counterparts. So lead is one, it's Pb. And iron is another one, it's Fe. Mercury is one for Hg. Silver is Ag. And those are just to name a few that are named after their Latin counterparts. This last one down here, this number is going to be the atomic mass. And what your atomic mass actually is, this is the average mass of all known isotopes. So this is what you find out from the periodic table. All right, I'm going to go back to this really quick. I want to add something. Electrons, protons, and neutrons. So I've mentioned the atomic number. The atomic number is the number of protons. Now this atomic number is actually, I'm going to start with that. Or branch off of that. So again, atomic number is the number of protons, and we have 3 subatomic particles in an atom. Protons, neutrons, and electrons. If you change the number of each one of these, you're actually going to end up with something new. So if I change the number, so we're going to make a chart here. I'm going to say when you change the number of. So when you change the number of either protons, neutrons, and electrons, you're actually going to end up with something new. So if I change the number of protons, so say I had carbon, which was a 6. If I add 1, I end up with 7. If you have access to a periodic table, you'll actually see that 7 is for nitrogen. So when you change the number of protons within your atom, you're actually going to end up with a new element entirely. So protons indicate the type of element you're dealing with. Now neutrons are different. Neutrons, which are also found in your nucleus, if you change the number of neutrons, you end up with an isotope. An isotope is something that, and just to be the same, an isotope is going to be an element with a different number of neutrons. Isotopes, a lot of the times, are used in radiometric dating. Carbon-14 is the most common one, and I will end this little section with that, or with talking about carbon-14 in a little more detail. So electrons. If you change the number of electrons, you actually end up with an ion. An ion. And what an ion is a charged particle. In your notes, there are two types of ions. We have cation and anion. The way I remember these, cats have paws. So a cation is a positive ion. So cats have paws. It's positive, which means it has lost an electron. That's a cation. Anion kind of looks like onion. Onions make people cry, so we think of negative. So an anion is negative. And if you have an ion has to do with electrons and it's negative, it means it has an extra electron, which is causing that negative charge. And that's because electrons are negative. So this is a gain of an electron. It should say gain. Let me rewrite that. This is a gain of an electron. Okay, very last thing for this is carbon-14. So when I see something like this represents an isotope. What this number up here is, this is actually the mass number. And what the mass number is, this is the number of protons and neutrons that you have in an element. So let's look at regular carbon. Carbon has a proton, has an atomic number of 6. So carbon has an atomic number of 6. In a neutral element, this atomic number will not only tell you how many protons you have, but it will also tell you how many electrons and neutrons you have. So if it's neutral, or if it's just a normal element, it means we have 6 protons and 6 neutrons. Our mass number is the number of protons and neutrons, so I'm going to add these together. 6 plus 6 equals 12. So a regular carbon element is going to have a mass number of 12, but we have 14, okay? So this means that this isotope actually has 2 extra neutrons. It can't have 2 extra protons, because if it had a different number of protons, it would be a different element. So that's what that means. One last thing, please go back up and add one more thing to your cation and anion part. If I have a cation, they're going to be written as using your chemical symbol and then there's going to be a plus or minus at the top. So sodium ion is a +1. It's missing one electron. Or you can have calcium ion, which actually is 2+. So that's just an example of how cations are written. Anions, you can have chlorine, or when we say anion, it actually has "ide" at the end. So instead of chlorine, it's chloride, nitride, oxide, fluoride, iodide. So you've probably heard of sodium chloride before, and that's why it's "ide" at the end. But anions are going to be represented by a negative value. Okay, so that is just a very brief lesson over the structure of the atom and how you look at the periodic tables. So hopefully you followed the directions and you wrote these notes down, or you added them to your original notes, and hopefully some of these concepts make a little more sense now. If you have any questions, please let me know. Thanks.